All right, I think we are live. I'm not sure if my video is coming through though. Oh, it is. Okay, well, welcome to those of you that were watching Tone. I was watching him as well. A lot of great things to say. So, this video is White Paper Wednesday. We do this on this show every once in a while. Every Wednesday, I try to read through a new BIP or white paper or something like that. So today we're going to go through BIP325, which is all about Signet. Again, this is from Carl Johan Ohm, Callie Wolf on Twitter, core developer out of Digital Garage out of Japan. Anyway, before I get to that though, let me show a couple of my stuff. There's the little Bitcoin book available on Kindle, Amazon. Kindle, paperback, Spanish, Portuguese audiobook. There's my book, Programming Bitcoin. It's available, I found out today, in Polish as well as Korean, and Japanese and Chinese are in the works. And of course, my seminar, Programming Blockchain. Today's the last day to get the early bird discount for San Francisco. Also doing it in Antwerp in April as well. Anyway, all that said, let's go take a look at BIP325. This is Signet from Carl Johan Ohm, like I said. Abstract, a new type of test network where signatures are used in addition to proof of work for block progress, enabling much more better coordination and robustness. Be reliably unreliable for persistent, long-term testing scenarios involving multiple independent parties. All right, motivation. Testnet is a great place to try out new things without risking real money, but it is notoriously unreliable. Huge block reorgs, long gaps in between blocks being mined, or sudden bursts of blocks in rapid succession mean that realistic testing of the software, especially involving multiple independent parties running software over an extended period of time, becomes infeasible in practice. Now, if you've been playing with testnet or do anything on testnet, certainly my book has a lot of the stuff done on testnet. This is very obvious, right? Like sometimes you get 20-minute blocks. That's about the maximum you'll have to wait. But other times you'll get like 10 blocks in like 10 seconds. That's because the difficulty on testnet is very, very low. And for that reason, you get some weird cases. Oftentimes, they'll reorg like 100 blocks or something like that, and that happens on not too infrequent basis. So that's what he's talking about. A new type of test network would be more suitable for integration testing by organizations such as exchanges or testing of next generation layer 2 protocols like L2 or sidechain pegs. The goal is not to be perfectly reliable, but rather to have a predictable amount of unreliability. You want a test network to behave like mainnet, no 1,000-block reorgs, while also making it easier to trigger expected but rare events like a 6-block reorg. Red test is not suitable for longer-term scenarios involving multiple independent parties because creating blocks costs nothing, so any party can completely control the test network. So red test is the other thing that you can use, which is great for sort of local testing, but for anything that involves multiple independent parties and so on, you really want something that you can all share, and something with 6-block reorgs. That's something that you often need to test and so on. So he's making the case that we really do need something other than red test and testnet. Specification, a new type of network, Signet, which takes an additional consensus parameter called the challenge, which is the script pub key. The challenge can be a simple pub key, pay to pub key hash style, or a K of n multisig or any other script you would want. The witness commitment of the Coinbase transaction is extended to include a secondary commitment, the signature solution. So the witness commitment of the Coinbase transaction is where the Coinbase money goes. That's where the op return is, and it has data about all of the SegWit transactions in that block. But it has a secondary commitment, which has a Signet header and the solution, a Sig script. So basically, you have to sign something in order for the block to be valid. For a full node on Signet, you need to do one more thing to assure that the block is valid. Any push operations that do not start with the 4-byte Signet header are ignored. Multiple push operations with the 4-byte Signet header are ignored except for the first entry. So only one of them is looked at. Any signature operations contained in the challenge use SHA-25060 or hash 256 of the modified block hash, i.e. the double SHA-256 digest of the following data as the sig hash: version, block, Merkle root, or modified Merkle root, end time, and end bit. So this is more or less all the things that go into a block. I think the only thing that is missing is block time. There's one. This is almost all of the fields that are in the block header. I think there's one field missing, which I can't. Oh, and nonce. Nonce is not in there. The modified Merkle root hash is obtained by generating the Merkle root of the block transactions with the Coinbase witness commitment as is without the Signet extension. So it can't sign itself, so it just has everything except the Signet extension that's in there. This means that the Merkle root of the block is different from the Merkle root in the Signet commitment. So the Merkle root's going to be different for that. And this is mostly so that it can be signed in the first place. This is needed because a signature can never be included in the very message that is being signed. So a signature can't sign itself. Apart from the signature to facilitate block generation mining, the block nonce value is the only other component of the block that the Signet signature does not commit to. When grinding proof of work, the extended nonce cannot be used as it would invalidate the signature. Instead, simply re-signing the same or an updated block will give a new search space. So you have to keep signing new ones as you run out of nonce space. That's why the nonce isn't a part of this. It's everything but the nonce, essentially, and you can't use what we talked about a couple of weeks ago, BIP325, some of the M version for some of the nonce. You're not allowed to do that because it gets committed to in the Signet. A block is considered fully validated if the above commitment is found and its solution is valid. It is recommended that both this verification is done directly before or after the witness commitment verification, as the data required to do both is approximately the same. And this is a good part of the design, is that you can verify the Signet stuff as part of the block. Compatibility. This specification is backwards compatible in the sense that existing software can use Signet out of the box. Simply by adding the network parameters for Signet, magic number, etc., a client can connect to and use any Signet network without further modifications. The block headers have valid proof of work, so clients can trivially check that blocks are probably valid. So they do have the proof of work, but most clients are not doing the additional validation of making sure that it's the signature next to the witness commitment is actually valid. However, anyone can mine blocks that are accepted by the client for any given Signet network. These blocks do not contain the required signatures, however, so any fully validating node will probably promptly reject them. As such, clients need to either validate the block signature inside the Coinbase transaction or connect to trusted peers. So, in other words, if you want to do the validation yourself, you're going to need to run a full node that has the public key and so on. Other software need not add block signature validation code that they will not use in production. This is adequate for non-production test purposes where the goal is to have a network behave as much like mainnet as possible. Reference into implementation is in this Bitcoin pull request, which is in BIP325. Let's take a look here. And it is in this one. It's still open. It hasn't been merged yet, but lots of interesting stuff here. There's like a README and all this other stuff. And essentially there's a Signet subdirectory that has like adding a transaction to block and all this other stuff to enable making Signet work. It's good work, and I recommend you use Signet if you need something tested more quickly. And you can create your own Signet, kind of like your own testnet, with signatures, and you can determine when the actual block gets out by using the right public key and so on. So that's what this BIP is all about. Really kind of an elegant solution, and we really should have more than one testnet. So very good stuff. Here are the other things again: Little Bitcoin book, audio, Kindle, hardcover, and of course there's Spanish and Portuguese. Here's Programming Bitcoin, and it is available on Amazon as well. Actually, I haven't looked at the English paperback in a while, but 104 ratings, 5 stars. That's pretty good, I'd say. There's also my book. I'm curious how it's doing on Amazon. If you look there, it has, I think, 4.5 stars. 40 ratings, 4.5 stars. So pretty good for both. And of course, my seminar, which has loads and loads of information and testimonials, and yeah, these are the requirements that you need in order to get there. And yeah, there's a lot of stuff. I should really put the testimonials on this page. I don't know. Oh, there it is, testimonials. Why is it all the way there? So there's a lot of people that have taken my seminar that you can take a look at here. And they've all said good things on LinkedIn or on Twitter and so on. So good stuff, and that's about it. Let's see if there are any questions. Yeah, I don't see any others. So hope that helps you. Fiat Delenda Est. This song is